Good evening, one and all. Let's start with today's session. In the last class, we discussed till the questions for the sample assignment for week 5. I guess one or two questions were left. Let's discuss that and later we can move on. Yeah, I guess we had solved this numerical. 2, 3 questions are left other than that. So let's do that. Give me a minute, please. Yeah. Am I audible? Okay. So, yeah, this was the question where we left. Yeah, so the question now uh, remaining is which of the following equipment is highly efficient, which has removal efficiency of 99% approximately for the removal of particulates have particulate matter having size greater than 0.01. So this is a very small size. And if we talk about gravity settlers, then this uh, can separate very bigger particles, maybe above 100 micron or so. As electrostatic precipitator and cyclone separator, they have moderate efficiencies like 1 to 5 micron or so on. While fabric filter is one of the most efficient, which can go till 0.01 to 1 micron as well. So the correct answer for this question is fabric filters. Next question is Reinluft process is related to dash. So it is a pollution control method which is specifically designed for the removal or the control of SO2 emission, right? Next is which of the following is not a disadvantage of wet scrubber? So the correct answer for this is the indifference to the temperature and moisture content of the gas because uh, wet scrubbers are not sensitive to any temperature gradient or the moisture content of the gas, while there are chances that the corrosion might happen or the generation of the uh, sludge uh, after passing water and particulates get absorbed. So in that case, the disposal of sludge, these all kind of are the disadvantage of the wet scrubbers. Next question is with increase in the particle size of particulate matter, the removal efficiency of cyclone separator dash. So here the basic phenomenon that plays role is bigger the particles, more will be the force acting, and easier will be the settling because centrifugal force is the force which is acting on the particle that leads to the separation, and it is equal to mv square by r. So more the mass, so bigger the particle, more the mass, and more will be the force, which can result into easier separation, right? So here, uh, the correct answer is with increase in the particle size, the efficiency increases. Yeah, so that's it uh, for the questions that were left for the last class. I hope it is clear so far. Uh, yes, anyone? Do you have any doubt? Okay, so if not, let's move with the next week's assignment as well as the brief of the lecture. So, till the last class, what we had discussed was uh, the pollution control in the case of air pollution, right? So, if we encounter air pollution, then what are the strategies we can uh, use for the control of the pollution, and how we can separate uh, different pollutants like SO2, NO2, carbon dioxide, and so on from the air so that we can have fresh air or purified air uh, in our surrounding. So another and one of the most important, you know, uh, pollution that we encounter in our surrounding is the water pollution. Okay, so as we know that our body itself is made up of like it is two-thirds of water, we can say, and water is the basic necessity not only for our body, our daily requirements, but for all the living organisms and any task we do. So, having an access to clean and pure water, depending on the purpose, is a basic need that we need to have. Now, with the fact that the pollution is increased, population is increasing day by day, there is an urgent rise in the daily requirements that requires more water, not only for the personal use by the person, but also for to meet the growing demands. For example, food, like water will be required for agriculture to meet the demands for more food. Then more land will be required, more their more basic necessity demands will be required. So in that case, everywhere water is required. So if water is polluted, or in all the cases, we need clean water. And if water is polluted, our um, uh, utmost or important role is to have a clean water, and therefore we need to have water treatment required in case the water which is polluted. Now, with the increasing uh, uh, industrial, industries because of the increase in pollution, with increasing population, there is an increase in the amount of wastewater which is generated from the household purposes. So, all like different uh, generation, there will be different generation of wastewater. Maybe the contaminants from household will be different from totally different from industries, but we need a separate uh, purifying or water treatment uh, facility so that the whatever water or wastewater is generated from household purpose and from industry, we are able to clean it and we can recycle and reuse that water also. So now if we talk about water, so basically we are uh, having at most or two main sources for drinking water, which is groundwater, which can include shallow wells and deep wells, and surface water, including river, lake, and reservoirs. Now, in case with increasing industrial activities and agricultural activities, household usage. In case you are dumping the untreated water in this, then it will pollute this stream. Or if we have generated water and it goes to gutter, then that like water from that has to be collected and it should be purified so that we can reuse it. So now our task is to have purification of uh, surface water and groundwater in case if our aim is to have, you know, uh, our aim is to use that water for drinking purpose. So, surface water and groundwater might have different characteristics because surface water is more exposed to human and it is more exposed to environment. There are chances that more, you would have seen that people just throwing their plastic bottles and other waste in the water bodies where they go for a trip, for example. So, surface water there are higher chances of contamination or like macro pollutants. It is uh, high chances of being present. So, first and foremost thing we require for surface water purification is screening. For example, if there is plastic which is present, there is glass which is present, any sort of food waste which is present. So all sort of bigger particles or bigger materials which is present in surface water that will be removed through the screens and micro strainers. So what you are doing, you are just putting us an obstacle by providing the size of that screen which is smaller as compared to the usual material size which is present in water. So once that is separated, then further there are chances that uh, very small particle or few bigger particles which are present, then we can have some pre-sedimentation. Each of these processes we will discuss in detail. So sedimentation is basically used to separate bigger particles or to allow the particles which are present in water to settle, and that can be separated in the form of sludge. Then there could be coagulation and flocculation, followed by sedimentation, filtration, and if any specific requirement is there, for example, if that water that has some organics or it has some odor and taste, then you can use adsorption. And obviously, if you are using that water for drinking purpose, then there are high chances that the surface water and groundwater is contaminated with microorganisms. So for that, you need disinfection. Now, contrary to that, groundwater has somewhat different characteristics, right? So groundwater requires somewhat different steps in purification if we want to use groundwater for drinking purpose. So first and foremost is the aeration and oxidation, which can result into oxidation of few organics or few contaminants, like which are readily oxidizable. Then for hardness removal, we can have lime soda process, which will result into the precipitation of hardness like calcium and magnesium salts which are present, and later there will be sedimentation of the precipitates which are found, and here in the lime soda process some of the carbon dioxide or the pH uh, changes during the operation. So by recarbonation, what we are doing, we are adding carbon in the form of carbonates and carbon dioxide. So that will result into maintaining the pH of the water. Further filtration will be provided, and obviously disinfection is required for drinking water purpose to remove the microbes. Now let's discuss each of these processes. Further, if we talk about municipal sewage wastewater or some industrial wastewater, some of the processes might be similar, but the sequence might be different, or some, in the case of industries, there might be some specific processes also used. So now let's discuss each of these processes one by one. And before that, if you have any doubt, please let me know. Otherwise, we can move forward. Yes, everyone clear? Yes, Krishna, can you hear me? Yes. Okay, so I hope it is, sorry, I hope it is clear. Let's move forward. So, we have discussed what are the processes that are required. Now, screening is nothing but you are just, for example, screens. If I give you an example of daily life, then screens are nothing but the chunni that you are using to filter tea. So it that will block the tea particles, and the milk or the fluid that that you drink, it will be it will pass through that stream. While the solid tea, it will remain there on the strainer. So what similar principle you are having, where you will put some strainer or screen that will filter your water. Now, once that is done, water has many suspended solids. So, suspended solids, like similar to what we discussed in air pollution, that particulate matters are present. So, similarly, here also some dust particles which might have entered into water, or some other particles or salts which are not soluble with, but which are um, suspended in water. For example, sorry, yeah, for example, colloidal particles. So these particles, nor they settle nor they dissolve. So in that case, what we do, if we want to separate, we can allow them to settle. But these particles are so small that under the gravitational force, so under gravity, they do not settle, right? So colloidal particles, they do not settle under gravity. And so for that, what we can do, we can increase the particle size. Okay. So how can we increase the particle size? So let's understand how, like, what are the colloids, and how we can increase the particle size so that we can settle them down. So for that, the process that we use is coagulation and flocculation. So if we look into the particles that are present in water, so these colloidal particles are as small as 0.001 to 1 micron size, and these are so small that it will remain suspended in water and it will not settle. Okay, further they are stabilized by the charges. Okay, so for example, if I have negative charge, then negative and negative charge will repel, and negative and positive charge they will attract, and like here the attractive force dominates, while here the repulsive force dominates, which hinders or which provides an obstacle or hindrance for particles to come closer so that they can agglomerate. Okay, so what we are utilizing here, what we want to do, because of the negative charge of each of these small particles, they remain separated. Okay, because of the repulsive force, the particles remain separated. Okay, because they have similar choices, they don't like each other. Okay, so like forces they repel, and that is why they remain separated. And since they don't come closer, there are no chances of aggregation or particles being merged, right? So in that case, what we do to remove this negative charge, we add one chemical which will result into neutralizing this charge, and further there will be some opposite charge which will be developed on this surface, so that the net charge resultant results in, like, net resultant charge causes this particle to come closer. For example, let's say these particles, here we are adding some chemical that causes some positive charge to add on it, and similarly, it will cause the two particles to attract. Now, this chemical which we add is nothing but known as coagulant. Okay, so when we are adding this coagulant, we mix this, and coagulants that we add usually are alum, ferric chloride, etc. And later, uh, now once they have mixed completely, we need to give some time so that they come closer and they form bigger particles, which are known as flocks, which have the dimensions in the range of 1 to 100 microns. Now, these sizes are much bigger as compared to the uh, previous or original particle size. And these particles, since they are bigger, they easily settle, right? So, uh, I guess it is clear to you all about the coagulation and flocculation process. But to do all this, we need some reactor, we need some mixer where we will do all the process. Right? So for that, we have one of the two most common tanks that we use is rapid mixer for coagulation to happen, because we are mixing the alum or the coagulant with the water. And here the retention time or the time which is provided for mixing is very small. So within a minute or even 1 minute, let's say, or within few seconds, the stirring happens and we are taking out water. So it will be a continuous process, and whatever the water which is entering, it might have a water contact of around 1 minute. While in the case of flocculator, the since we want particles to come closer and form bigger particles and settle, if we provide faster agitation, then what will happen? Even if whatever has settled, it will not settle, like it will come upward. Okay, if we provide more agitation, the particles will break. So here in the flocculator, we provide slow agitation and higher detention time, higher detention or higher time we provide for particles to grow and settle. So higher time will be provided in the reactor. So reactors are designed in such a way that more contact is provided in the flocculator, while in the case of coagulation tank, we have a very rapid mixing. So is that clear so far? Yes? Okay. So now whatever has settled that goes through sedimentation tank. And after that, also further, if there are many small tiny particles which are left, then what we provide is sand filters. So sand filters, it is the tank which has gravels, small stones, sand, etc., which are layered, and we allow the water to pass through this. So as the water passes through this, the tiny particles they stuck in between all this. material and they get separated from water. So here there could be inlet and this could be the outlet. Now, in case there are chances that here the separation occurs through, for example, if there are two sand particles, let's say these are two sand particles. So whatever is the gap and whatever the particle which is flowing through this, so water will pass and the bigger particle it will stuck here. Okay. So in a way it is blocking the passage um, for water to flow. So over the period of time, there are chances that more blockage might occur and more pressure drop would happen. So we need to clean it by so for that what we do we allow the water to backflow and by providing backflow we are washing the sand filters so backflow washes sand filters, right, and so that we can reuse those sand filters again. Now if we talk about hardness which is present in water, so surface water and even groundwater might possess some hardness, but in case of groundwater, the hardness might be relatively higher. So to remove hardness, sorry, we can use ion exchange method. So can anybody tell me what is hardness and like this we have already discussed. So what is hardness and how like what ions contribute towards hardness and like what do you know about hardness? Yes, yes, anyone, please. Sainika. Okay, so I request actually whenever I ask, it would be good if you respond so that if we have an interaction, uh, it will be better for you and me as well. So, yeah, so hardness is because of the presence of ions that include just a second, yeah. So that include Ca2 plus, Mg2 plus, um, and some other. Wait a minute. Can you listen to me? Wait a minute, it's not working. Hmm, Can you hear me? I guess my laptop has stuck. Sorry for this. Give me a moment so that I can fix. Yeah, I guess you're able to see the screen, but I'm not able to write and I'm not able to um, change my slide. Wait for a minute till I